Okay, heading into the last section before we take our chapter test over the first half of chapter 1. Our topic today is what's called increasing, decreasing, and constant functions. And then also this fancy math word called extrema. We're going to start with that. It is a fancy math word, but what does it mean? It means the maximum value or the minimum value in your graph. So we will see that word again. It'll ask you to identify the extrema. Extrema just says maxes and mins. And maxes and mins are exactly what they sound like. They're maximum points, minimum points. My non-math way of describing them is if I were to ever look at my picture and see the top of a hill, any top of a hill would be a maximum, okay? Now, our extrema are categorized into two types. They are either relative or absolute. And it is completely categorized into that if it is the maximum, but not the highest point in my graph. So it's the top of a hill, but there's graphs somewhere else that's actually higher than that. The blue dot in this picture right here would be an example of a relative maximum. It's the top of a hill, so we call it a maximum. But there is graph right over here that is higher than that, so it's not the highest point in our graph overall. So relative maximum. An absolute maximum talks about being the absolute highest point in our picture. So it's the top of a hill, and there is nothing else higher than that in the graph. So over here, this red dot would be the top of the hill, and it is the highest point in our graph, absolute maximum. So today we'll categorize by those two words, absolute or relative, and then max, and then what we see on this next page, minimum. And minimums are, my non-mathematical way of describing them, the bottom of a valley. So if we ever see any bottoms of valleys, that would be called a minimum. And again, categorized into the two different types. Relative minimum means it is the bottom of a valley, but there is graph somewhere else in the picture that's going to be lower than that. So like this blue dot right here is the bottom of a valley, but it's not the lowest point in our picture, so we would call it a relative minimum. The red dot is the bottom of a valley and the lowest overall point in our picture. We would call that an absolute minimum. Now, you have four options for extrema: absolute and relative, maxes and mins. You can have any combination or number of any of those four types. So you can have multiple relative or absolute maxes or mins. You don't have to actually have any. So there's no like set number like, oh, once I've found one of each type, we're done. You could have 3 relative minimums and nothing else. Okay, you can have all sorts of different combos of these. So there's no number. You can have multiple absolute minimums and multiple absolute maximums if they were to go to the same max value. Like instead of this one going here, if it dipped down to that same height here, those would both be considered an absolute minimum. They would both, if they go to the same, if they go to the same lowest. If it is the lowest, but there's more than one of them there, they're both called absolute.
So how could you have 3 relative and 0 absolute when all 3 be absolute?
The ends of our graph kind of will do that for us. So like if we were to have 3, what'd you say, 3 relative minimums? So a minimum, another minimum, and then our graph goes down here. So all of these are relative, and there's graph lower than that. Yeah. So big, if it bounces a whole bunch of times, it can have a whole bunch of maxes and mins, because this one has then 1, 2, 3 relative maximums in that picture too. No absolutes, because this keeps going up forever. So that's what we're looking at here. So I want you to look at the directions up here. I have crossed them off. You guys are going to mentally do that same thing when you get to your assignment today, because we are never going to estimate. We're going to go straight to our calculators, and we're going to find exactly what they are, okay? So it says classify the extrema for the graph, support your answer numerically. We're not going to do that. We are just going to figure out what they are from our calculator. As a rule, we are always going to round to our nearest tenth. So if you guys will grab your calculators, what I want you to do is get this typed into Y1. Use this picture right here and let it help you make an appropriate window. You can adjust the window a little bit, but it kind of helps you be able to see the whole picture. If you notice, this goes down to like -16 and up to 16. So adjust some stuff on your window so you can see that. I'm going to grab my calculator so I can show you the function that allows us to find our extrema. So again, get that typed into your Y1, go to your window. I'm going to adjust it a little bit different than that just to make mine bigger. I'm going to zoom in just a little bit more than they did. So like to see the bottom of this, I just need to go to, I don't know, maybe like -10 or something. That's in our Y's, but I'm going to zoom in just a little bit here. So like I'm just going to go from -6 to 6, -10 to 16. Just gives me a little bit closer of a picture. It's the same picture, just zoomed in a touch. The more you can zoom in and make it a really nice centered picture, the easier it is to find your extrema using our calculator functions. So as we look at this picture, again, extrema, I'm looking for, as I scan all the way across, are there any bottoms of valleys? Yes. As I scan all the way across, are there any tops of hills? Yes. So that means we have extrema to find. Pick one of them, do one at a time. Okay, so I'm going to start on the left-hand side here. I see the bottom of a valley over here. So I know in my head that that is a minimum. So when we are identifying these, first of all, it is going to be a three-word process or three-thing process. Your first word you will pick between relative or absolute. Your second word you will pick between max and min. And the third thing you put is the point that your calculator tells you. And you just literally read that off your calculator, okay? So I already said we're finding this minimum, and the reason we want to identify that first is because this is where we go. Everyone ready to hit the buttons here? Okay, to find a minimum on your calculator, you are going to go to your second key. And remember where we got our zeros? Minimums are in the same place. So go to second trace or second calc. We've been using option 2, 0. Now we're going to be using options 3 and 4, minimum and maximum. So we're going to go down to, I'm finding the minimum first, so I'm going to pick 3, minimum. And it asks you the same questions it asked you when we were finding zeros. Move a little bit left of it. So again, if I want to, I can think about this being an imaginary vertical line that's running through where that minimum is. Put my bug somewhere to the left of that spot. So I would move to the left of where I see that minimum. Somewhere, it doesn't matter where, somewhere left of my minimum, and hit enter. Move somewhere to the right of it, and hit enter. Give yourself a little breathing room, don't be super close to it. And go to the 10th, hit enter, and enter to skip guess. What you're doing is giving your calculator a window to look in, and all it's going to do is look inside that window and say, what is the lowest value in that window? So if you set the window wrong, your calculator will tell you the wrong answer. So it's up to you to set the correct window space for it to look for a minimum, okay? Just right around where your minimum is. Okay, so just make sure you get actually to the left and the right of where that minimum happens. So here's our answers. First of all, answer me this. Relative or absolute?
Relative.
Relative. Over here, this is going to continue down for, that is lower than that, right? So this would be a relative. We said it's the bottom of a valley, which is a minimum, and then I just read the numbers that my calculator tells me and round to my nearest tenth. -1.2, -7.9. Okay. And then we repeat the process for any other valleys or hills that we see. Well, I see another hill. I see a hill in our picture, right? And a hill is going to be a maximum. So I go back to that same menu, second calc, pick option 4 for maximum. And again, I'm now going to go close to the top of that hill. And I start out being a little bit left of it. Hit enter, move to the right of it, hit enter, and enter to skip guess. And again, we go through that 3-word process, okay? This hill, relative or absolute? Relative. Again, over here, this graph's going to keep going up. There is going to be a graph higher than the top of that hill. So we would say relative, it is the top of a hill, so maximum. Round to my nearest tenth, 2.6. Please round correct, 2.2, round correctly. And 14.6, as I'm telling you to round correctly and I don't. All right. What questions do you guys have for me on this so far? This is a getting to know our calculator process. There is kind of a happy balance between not being too close to the top of the hill or the bottom of the valley and not being too far away. So find that little sweet spot where we're not overlapping anything else. We are close enough to the left and the right of it, but not so close that we didn't actually get over the hill or whatever to the other side. Yes.
What would happen if you had your minimum and calculated?
Yeah, so I can do a minimum for any part I want. I don't have to go on either side of it, but it's just going to find the minimum in that window. So, for example, if I were to do that, what if I just did a minimum like from, I don't know, here, and I said that this was left of my minimum, and then I went a little bit further to the right, and I said this was to the right of my minimum. Basically, I said, okay, calculator, tell me what the lowest value is in that little window. Well, it's going to, and it's going to tell me it's right there. But that's not actually a minimum. So this one takes a little bit of us knowing what we're looking at, because it will tell me what that is, but I didn't set my window right to find the bottom of a valley. Okay. Okay, you guys try one on the next one. Your function is x to the 5th plus 3x squared plus x plus 1. You try this one on your own. Set your windows to make that a little bit bigger. You can, I would reset it from what we had here, because you can zoom in quite a bit on this one and make it a really nice big picture for yourself. Three-word process, relative or absolute, max or min, ordered pair. If you're having trouble with your calculator, this is a good time to get me to help. Okay, I got myself a really nice big picture. I only went from like -3 to 3, okay, and it really blew it up nice and big. If you don't, this one gets kind of small. If we go like a zoom 6 window, it's pretty small, and you have to be very careful about where your bug is to make sure you like don't overlap the next part or anything. So I just zoomed in a little bit here. I see the top of a hill, so I'm going to pick my option 4, which is a maximum. I'm going to find this one on the left here, the top of my hill. Move a little bit left of it. Hit enter, move a little bit right of it, hit enter, enter to skip guess, and it tells me that that maximum is happening at, ooh, I'm glad it did this on my calculator, because I've now done this 3 times today. Once it rounded to a whole number, and the other 2 times it's done this, okay? So I don't know if it's how much I've zoomed in or not. Who in here's calculator said -1?
First time I did it, said that.
And then, yeah, so it doesn't matter. Same calculators will sometimes, remember we talked about your calculator will do weird things? Mine did a weird thing here, right? That's -1. And it really is actually at -1, so -1 comma 2. If I rounded that correctly, it would have told me -1 anyway. Now, my answer's not right yet because I'm missing the first word. What is the first word that I should have put on this one? Relative. It is not the highest point in my graph. All right, and I'm going to go find the bottom of that valley using my minimum. Nearest 10th, but 0.99999 rounded to the nearest 10th actually does bump up to 1. Because the 9 would bump the next 9 up, which would bump up to 1. If that makes sense. All right, and our next one is a minimum to the nearest 10th, -0.2. 0.9. Relative or absolute? Relative. Okay. Now we have done 4 of them, right? And all 4 of them have turned out to be relative. Agreed? Okay, this is not something you have to have memorized, but it is a true statement. If you look back at the polynomials that we had for each of those, what was our biggest exponent? A 5. What do we know if the exponent is an odd number? Don't we have the one side points up and one side points down, right? Okay, so it's, love it, always going to be relative. They have to be, because one side of my graph is going to go down forever. Nothing can be lower than forever, right? And one side of my graph is going to go up forever, so nothing can be higher than forever. So when it is an odd exponent on a polynomial, you can never have an absolute because your graph keeps going in both directions. It's when we get to this next one where we start having even, where the ends of my graph go the same direction, that we are now even eligible for absolute. Do we need to remember that? No. Is it true? Yes. So let's do our last one here with our extrema. I think it's kind of small up there, so let me read it to you. It is an x to the fourth minus 5x squared minus 2x plus 4. Same thing here. If you're having any trouble finding your maxes and mins, let me come around and help you here. And if you're having trouble reading it, I've got it typed into my calculator here. You guys can look at that too. What's this one? 3 right here.
Okay.
There you go. Yep.
Just flip it upside down.
You have a plus 2x.
How's that just flip it?
There you go. Yep. All right. So we've got the even exponent. We see the both ends of our graph heading the same way. As you guys are finding your extrema on this, how many answers are you finding me right now? 3. Okay, if you did not see 3 as you initially looked at it, scan back across your graph. Look at it one time to find valleys. Look at it a second time to find hills. And again, if you're having trouble finding any of those, let me know. All right, check your numbers with what I have on the board. Again, my answers are not done because I did not finish the first word on any of those as far as relative or absolute. So again, one more time with the whole identifying relative versus absolute. Working our way from the left to the right, the first bottom of a valley, my minimum is that top one, relative or absolute? Relative. There is graph over here lower than that. So it is a minimum, but not the most minimum. That is a relative. Okay, how about our maximum, the top of the hill in the middle? Relative. And the last one, our first absolute minimum. It is the lowest point overall and forever in that graph. Sailor. Nope. Nope, there is no correct order to finding these, okay? Just make sure they're all there. And again, remember, there is no set number. You can have numerous of each and every type. You don't have to have each and every type. Maybe we only have a minimum. Maybe we have numerous maximums. It doesn't matter. Number of each type. Any other questions? You can. Let's pretend, if I look at this picture, let me zoom in on this picture a little bit here. You technically could. If I were, instead of this one only going to here, it dropped all the way to the same exact y value that that one did, those would both be considered absolute minimums if they went to the same, because they're both the lowest point. Does that make sense? It would be the same y value. Yep, they would have different x's. They would have different x's, but they could be the same. So you technically can have more than one, and we will see that eventually. More than one absolute, they just hit the same y value, different x's. All right. Our second topic is what's called increasing, decreasing, and constant. What is our graph doing? Okay, well, what I need you to do is remember how you were taught to read a word, a sentence, a book, from left to right. Everything we do is from left to right. Well, reading a graph doesn't change that. So when I ask you about increasing and decreasing, you are saying, if I were to read my graph or trace it from the left to the right, is my pencil going up, down, or nothing? Okay, well, if it goes from the left to right and it's going up, the word we use is increasing. Okay, if I trace my graph from the left to the right and my pencil is headed down, we call it decreasing. And if it doesn't do either of those things, if I trace it, which would only be this little section right here, but if I trace to that part of it, it's not going up or down, it's what's called a constant function, a horizontal line. We're not going to spend much time talking about constant functions, but they do exist. So if you weren't able to categorize a part of your graph into increasing or decreasing because it doesn't go up or down, it's called constant. Okay? So here's what we are going to do. Again, we are not estimating ever. We are going to find the exact answers for this. I don't think you necessarily need to do this in your calculator because I think we can tell exactly where that minimum is. I can help us out with this. But basically, when you are doing an increasing or decreasing question, you are reading your x-axis to see what the different intervals are of your graph, and you're just categorizing them. In that interval, is my graph headed up or is my graph headed down? Okay, so here's what I want you to do, is you're going to mark up your x-axis, and it will tell you exactly what those intervals are. Your x-axis, first of all, goes like a number line from -infinity to infinity. And then you're going to make marks anywhere along here that you have a max or a min. Well, we only have one of those in this picture, right? We have a minimum, and it happens here. That ordered pair would be 0, -4. Well, guys, we're marking our x-axis. So when you identify your extrema, your maxes and mins, when we're talking increasing and decreasing, I really only care about the x value of that. So I'm going to go up to my x-axis, and I'm going to mark where that break happened, and that break happens at the x value of 0. And there's your intervals. My interval from -infinity to 0, and then a second one that goes from 0 to infinity. Okay? And what we want to do is we want to focus just on one interval at a time. As you're getting used to this, you might want to physically cover up the rest of it. So like I can pull this little shade here and just look at the interval that goes from -infinity up to 0. And if I just look at that picture, again, read it from left to right. If I were to trace this from left to right, my pencil is headed down, which makes that piece of graph decreasing, right? So that interval from -infinity up to 0 would go under the category called decreasing. Then I look at the other part, which would go from 0 to infinity. And again, if I trace this as I read from left to right, my pencil is headed up. And up means increasing. So the interval that goes from 0 to infinity is increasing. Now, that seems very simple. However, the numbers start to mess with your head because you want to, and this is not a great example to not mess with your head, you want things like positive infinities to be increasing, but remember that those really have nothing to do with each other. Our answers are moving from left to right. The picture going up and down is what's telling us where to put them, and so the whole up, down, left, right thing starts to mess with you with increasing, decreasing. Okay? So again, I would just force yourself to read the graph from left to right along your x-axis. Let's try another one. You guys are going to find for me the extrema on this graph. So if you will grab your calculators real quick. The function we're looking at this time is -x³ plus x. Please type that in and find the exact maxes and mins on your calculator for me. So when we're doing increasing and decreasing, the first thing we're going to do is just identify the location of all of our extrema. And really, I mean, you can write down both parts of it, but really what we want is the x value of our extrema. Where is it located along our x-axis? Reason being is maxes and mins are when it changes from things like increasing to decreasing. So that's why we have breaks in our intervals there. All right. Who's got the minimum for me? Give me the numbers here. Okay, and our maximum? Okay, we are marking our x-axis. I want to use my x's, so ignore your y values. Take that x up there, mark negative 0.6. Take that x value down here, mark 0.6. And again, there's the breaks from negative infinity up to negative 0.6, negative 0.6 to 0.6, 0.6 to infinity. Those are our intervals. That's our first interval. We'll look at it individually. Our second interval, again, I'm just reading the different numbers that are across my x-axis. And our last interval, 0.6 to infinity, okay? So one at a time, and I have a harder time covering this one up, but if I just look at this part from negative infinity up to negative 0.6, trace that piece of graph from left to right, headed down. So that interval goes under decreasing. Then I look at the next one, negative 0.6 to 0.6, I trace from left to right, and I go up. Up is increasing. And your last one, so again, just look at this interval. I trace the graph, it heads down. Down is decreasing, and that's the one I want to look at right there because that's the one that messes with people. I just put the number, positive infinity, on the decreasing line. Remember, those don't have anything to do with each other. That's just telling me what part of the graph was headed downhill. So think of, again, downhill, that's where it was happening, right, on our x-axis. So don't let those numbers stop you from putting it in the correct spot. Any questions on increasing or decreasing? Mark up your x-axis, read your x-axis, look at each of those intervals, and put them on the right line for increasing or decreasing. The last thing we're going to talk about is taking a step back from the step-by-step and evaluating based off of a story. One of the things we're going to do a lot this year is ask you to be able to graph something on your graphing calculator where you have to figure out an appropriate window based on the situation. We've kind of talked about this before a little bit, called like relevant domain. Remember that word? So let's read through this one and kind of figure out what our relevant domain and range for this would be based off the situation. It says advertisements for a new car claim that a tank of gas will take a driver and 3 passengers about 360 miles. After researching on the internet, you find the function for miles per tank of gas is f of x equals, and then that function right there. And it tells us what the x stands for. X is the speed of our car, okay? So as we think about drawing a graph for ourselves, our x-axis is our speed. That's what it just says right here, right? X is the speed. Function, remember function, f of x is the same thing as our y values, is our miles. Okay, let's talk speed. What would numbers be for our speed? Well, what's the slowest speed you can go? 0, right? So if I was adjusting my window to this, the slowest speed I'm going to go is 0. So along my x-axis here, I would make the x minimum 0. So if we're talking our window here. Okay, how about our x maximum? 80, probably a top speed that we should appropriately drive, right? Now, when I'm creating a window for myself, I do want to give myself a little bit of breathing room. So if 80 is probably the fastest I'm going to drive, I would go out just a little bit farther than that so I can see a little bit better. Maybe 100, 120. I'm not saying that's how fast we're driving, but just giving me a nice picture to see would be something. And this is also a number that I would totally guess and check. If I don't think that that works out nicely, I try a different number and see if it gives me a better picture one way or the other, okay? Now let's talk about our y values. Our y, our function, is the miles. What's the least number of miles we're going to drive? 0. Okay? Now if they're telling me that this car that I'm looking at drives 360 miles, okay, that's an average. Obviously, again, we want to give ourselves some breathing room there think about more than that. Actually, if I think about my car, I think I get somewhere around like 430-ish a tank. It's got a really big tank. 430, so maybe 450. Give yourself some breathing room above that. But that gives you at least an idea of what to head up to. Okay, so the last thing I want to talk to you about is that whole scale thing. So we just would have put our Y min at 0, our Y max at 450, and the whole scale thing. Now yours is probably set at 1, which is fine, except for it's telling you how often it's going to put a tick mark. Okay, well, if we're going up to 450, it is now going to draw 450 tick marks in your little calculator window, which is just going to look like a big fat bar up the side of your calculator. You could adjust it if you want to. You don't have to, but it's going to look a lot nicer if you do. If we're going up to 450, maybe you go by 10s or 50s or 100. It doesn't matter. Make it look something nicer. If you like them to match, they don't have to match. Your scales don't have to match. Right now, I'd have 100 tick marks on my x-axis. Maybe change that to 10 or 50 or whatever. It doesn't matter what you change it to, but I wouldn't leave it at 1. You can. It's going to look ugly. Okay, so then we graph it. Go ahead and graph it. Type that in, graph it. And let's talk about the question that's going on up there. Do you know how to put that in there? Second, insert, negative. You don't have to retype the whole thing. Let's see if that makes it better. Sure does. Okay. All right, so we should have gotten a picture that looks something like this. What are we seeing? We're seeing a little tiny bit of the top of an upside down parabola. I know it's a parabola because it's an x squared, right? Okay, but it's an upside down one because it's a negative out front. They ask us what speed optimizes. Okay, let's talk English words here. Optimize. If I'm going to optimize something, give me some synonyms. Most. Maximum. Have we heard that word today? Maximum? Yeah? Okay, that's what it's asking you. If we're supposed to be optimizing this, they're asking you what is the maximum. You guys have this beautiful function on your calculator that finds that. Go find that. Put your bug a little bit to the left of the top of this hill. This is a very wide hill, but there is a top to it, right? Put your bug a little bit to the left of it, a little bit to the right of it, enter to skip guess. And it's going to give you an ordered pair where that maximum, that optimization of this function is happening. And then we need to talk about what those numbers mean so that we can answer the question. If I remember correctly, it was something like 70, 3.5. Okay. Now, in an ordered pair, it always goes x, comma, y, doesn't it? And our x's and y's have labels in this situation. Our x is the speed, and our y is the number of miles. Okay, now I can answer the question. The question is not the ordered pair, or the answer is not the ordered pair. From that, interpret to get the answer. What speed optimizes the distance? Okay, the question is what speed? Well, of our ordered pair, speed is the first number. Does that seem appropriate? 70? Yeah, that seems like a normal speed. 70 miles per hour. Second question, how far? Far would be miles, and that's your second number. Does that second number seem like an appropriate number for a tank of gas? 362.5. Okay, so the last part of this whole thing that people tend to lose at the very end of this is answering the questions correctly. The answer is not the ordered pair. What are the labels? What does that mean my X stands for? What does that mean my Y stands for? And use that information to help you answer the question. Questions for me. 362.5? Okay. We might not have gotten far enough over the hill as we did our maximum. All right. Your assignment is on page 40. I kind of highlighted for you which parts you are doing the increasing and decreasing and which parts you are doing to find the maxes and mins.